Please wait. Okay, in yesterday actually, one of you told this class today. This class you want to shift to 11 o'clock or 12 o'clock?
Sir, 11, sir. Or
11.
12 also works, sir, actually. We are free till 12:40, 11 from 11 to 12:45, sir.
That 12 is it will be difficult maybe because from 2 o'clock my another class is there. So 11 is okay if you all of you agree. So all of you agree, then please tell me through yours here.
Okay, sir.
Is it okay?
Okay, sir.
So you can inform through yours here. This class need to be shipped to 11 o'clock or not. If then we can take this class in 11 o'clock in the next week.
Okay, sir.
Okay. Can you see PowerPoint presentation in my laptop?
Yes, sir.
Yes, sir.
Okay. So only 23, including me. Only 27. Okay, it's better. We can start. Some of the students maybe join later, but there are 32 students till or 31 students. Uh, Today, I want to start the ER data model, uh, entity relationship data model. This data model based on the object-oriented model. Uh, in one of my beginning class, I told you the different data models. Uh, is it na? Different data model, record-based logical data model, object-based logical data model, physical data model, so on. Record-based logical data model, there are three.
Sir, are you presenting the slides, sir?
No, no, just okay, just this one. Okay. Now, PowerPoint presentation is you can see. Is it na?
Yes, sir. Yes, sir.
Okay. So, though our syllabus, that is the record-based logical model, there are three categories are there: the relational data model, hierarchical data model, and network data model. And in past and as well as present and maybe in future, the relational data model is the most popular one. And this model, that is our syllabus based on this model, relational data model, model that is also important in some extent. Why? Because in this data model, by graphically, you can represent the different objects. Objects are the your entity, and as well as the among the entity there is some relationships, and from that the graphical representation, you can easily convert into a table. So, so, so this actually gives the basic structure, and from that you can convert in a your relational data model. In relational data model, you know, there the collection of tables are there. The data actually stored in the table, and all the tables stored in a one of the special file. What is the this is known as the data dictionary. Uh,
Sir, we can't see anything,
so
sir. It's only the first slide, sir.
I am not showing any slide. This is the first slide. Why I want to or our syllabus or most of the syllabus include the this chapter. Though most of the syllabus this is based on the relational data model, and there is a entity relationship data model is present in our syllabus. And what is the importance of entity relationships model? And that can help to your relational to design the relational data model for a particular organization. When you have designed any database for a particular organization, at that time the entity relationship model can help. Okay, so before starting the relational data model, we can first complete the entity relationship model, that is the ER data model, and then we can start the relational model and the corresponding pure query language and as well as the commercial query language database design. All are based on the relational data model. Okay, so first actually I want to cover the entity relationship data model. uh, I already told most of my discussion or content of the slides based on the database system concepts, the book of Silver Scratch and Croft, and this covers the entity set, relationship set, design issue, ER diagram, mapping cardinality, different keys, extended ER features, entity relationship features, and so on. So first here in ER data model is based on the perception perception of the real world, perception of the real world, which consists of a collection of objects, collection of basic objects, and these basic objects are actually called an entity. That is, this collection of basic objects is called a entity. That is, here the database can be modeled as a collection of entities and relationships among these entities. Okay, relationships among these entities. And what we told, the entity is an object that exists and is distinguishable from the other object by some by using some property or by using some features. Suppose a person is the one of the entity, but suppose the name of the person Omid and another person say Vikas, both are the entity, both are the distinguishable objects, and these objects are how actually distinguish Omid and Vikas by some features, by the name, by the uh, person ID or customer ID, or maybe the uh, voter ID card or something identification number, phone number, address. Is it? That means a particular person or object is described by a some features. Okay, and that can distinguish from the other object. Maybe the same type of the Omid and Vikas both are same type of entity, say person type, though they are different. That is when the similarly the company. Suppose the one of the company name is say ITC. Say ITC some particular area, and maybe another company name is say DSP. So both are actually company or industry, but they have some different features. Okay, so entity is an object which actually exists and distinguishable from the other object. And whatever actually I told, that any entity have some features. These features are known as the attribute. That is, entities have some attributes, and entity set is the set of same type of entities. Whatever actually I called just before that, the Amit is the one of the person entity, Vikas is the another person entity, say Deepak is the another person entity. So collection of this same type of entity is called a person entity set. That is, entity set is the set of entities of the same type that share the same property. Property means the name of the here set of person or companies and trees. This is the one example here. Just a minute. Here number of entities are there. This is a customer entity set. This is a customer entity set. Okay, this is the entity, first entity, second entity, okay, so on. And in this customer entity, what are the features are there? These are the customer ID, customer name, customer street, customer city. There may be other features are there. These features are actually called, these are the attribute. Okay, you can come later. So suppose this entity is the name is the Hayes, customer ID is the, this one is the customer ID, and which city he belongs, Harrison city. Okay, similarly, that is in this entity set, customer entity set, in this example there are 7 entities are there. 7 entities are there. 1 2 3 4 7 entities are there. Similarly, say another entity is the loan entity. This is the loan entity. This is the loan entity set. Okay, and each of the entities, this is the first entity, second entity, and so on. How actually distinguish two entities belongs to the loan entity set? By the loan number and amount. Is it clear? And these entities in this entity set are described by loan number and amount. amount of the loan. Okay, and whatever I already told, the entity is represented by a set of attribute. That is the descriptive property. That is any entity here, loan entity. This loan entity is described by loan number and amount. That is the loan amount basically. So the customer is the entity set. This is the attribute 1, attribute 2, customer name, attribute 3, attribute 4. Similarly, the loan entity set, what is the name of the attribute? Loan number and amount. Okay. Now next is the some domain. Domain of the attribute. What is the domain of the attribute means? The set of permitted value of that attribute. Domain of a particular attribute means set of permitted values for this attribute. Okay. Up to that, any question? Is there any question? No.
Yes, sir.
No, sir.
Okay. Next, different type of attribute. The first one is the simple attribute and composite attribute. Simple attribute means the simple attribute. Simple attribute means, for example, this amount. Amount is the simple attribute. Loan number. Loan number. Loan number is simple attribute. Okay. And composite attribute means that may consist some sub attribute. For example, say address. For example, address. Address. What are the sub attribute of that address? Or address may contain. Address may contain, say, flat number or building number, building name, street, city, and so on. Say for example here, say address. Address is the name of the attribute. Why it is composite? It may contain a attribute, say street name, say city, say pin code or zip code. Okay, or maybe the building name, building number, and say name and or name. Okay, so here you can see that this address is the composite attribute. Why? Because it contains the number of other attributes. Building number or building name is the one of the attributes. Street name is the one of the attributes. City is the another attribute. Pin code is the another attribute. So for that reason, it is called a composite attribute. Maybe another example, say date. Date. Date is also a composite attribute. Why? Date contain day is the one of the attribute. Month is the another attribute, and year is the another attribute. Okay, so what is the simple attribute means that cannot be break. That is this one is the atomic in that sense. The amount is atomic. It cannot be break. But composite attribute means it can be break by a number of attributes. Okay, is it clear? I think. Second one, the next one is the single valued and multi-valued. Single valued attribute and multi-valued attribute. What is the single valued attribute? The single valued attribute means amount, loan number. This is single value. The loan number is a single value. Amount is also a single value. Okay, that is amount. But multi-valued is the phone number. Multi-valued means the attribute may contain one or more any number of value. Okay, the phone number is the multi-valued attribute.
Sir, what
Next
is the
type
difference
is
between single valued and multi-valued, sir?
Single valued means it contain a single value, at most single value. That is, for example, amount, loan amount. Loan amount is a only one amount, maybe 10 lakhs, maybe 5 lakhs, maybe 10,000, maybe 5,000, whatever the amount of loan. This is a single value or loan number. For a particular loan, only one loan is there, na? But for a particular customer, suppose you or myself have a more than one phone number is there. More than one number is there. So phone number in that case is the multi-valued because it phone number attribute may contain any number of values, more than one values, one or maybe more than one. But not necessarily every time it can contain a more than one. Is it clear? Multi-valued means number of value, possible values it can contain, and single valued means only one value for that attribute. Of course, a particular entity. In a particular entity, suppose for example, say customer entity. Customer entity, say this one is the customer entity. In customer entity, customer ID of a particular customer, only one value is it not? So it is a single value. But if here phone number is there, in that case it is not shown. If phone number is present in the customer entity set or entities, that is the phone number attribute, then this phone number is the multi-value because for a particular customer there may be one or more phone number is there. I think it is clear. Next one is the derived attribute. What is the derived attribute? Derived attribute means can be computed from the other attributes. For example, age. Suppose age is the one of the attributes, say. So how we can compute the age of a customer or maybe the age of the employees or age of a person or age of the students? We can compute from the date of birth. Say date of birth is the another attribute. Date of birth is the another attribute. We can compute this age. The age is also an attribute, but this attribute is not supplied. It is derived from date of birth. Okay, date of birth actually given. Is it clear? That is when one of the attribute value is derived from the other attribute is known as the derived attribute. In this example, age is the derived attribute. Is there any question?
No, sir.
So the different entity sets or entities are associated. That means one entity is associated with another entity by a or via a relationship. That relationship is an association among several entities. For example, say Hayes is the name, customer entity. Hayes is the name. Name actually belongs to in which entity? Customer entity. Hayes, this customer entity and as well as the account entity is associated via the relationship set. What is the name of the relationship set? Depositor. Okay. So here these two entity set, this entity set and account entity set, that is the customer entity and account entity, is associated with the help of a relationship. So in this example, what is the name of the relationships? For example, depositor. Say the name is appropriate, I think, because the his is a one of the depositor. What is the account number? A102 is the account number of the his. Okay. And of course, the relationship set is the set of same type of relationships. It is a relationship set is a collection of same type of relationships. Okay. So formally or mathematically, the relation among n greater than equals 2, that is 2 or more entities, is taken from the entity set. Then R is relationship set. R is a subset of this. Subset of this, where E1, small e1 is the capital E1. This capital E1 is the entity. This is a entity. Okay. This E2 is also an entity set. E2 is also an entity set. En is also an entity set. Okay, and small e1 is the small ei is the entity belongs to entity set ei. Okay, is it clear? The whatever the in color I can choose, is it visible or clear from your side? The in color, is there any problem in the in color? The color
No,
I
sir.
have chosen, is it visible from your side? Is it clear? Na? Okay.
Yes, sir.
So mathematical relation, it is a formally defined as a mathematical relationship taken from the each of the entity set. That is, R is the subset. Relationship set is the subset of entity from the participating entity set, capital E1, capital E2, capital En. For example, say, say here the depositor relationship, that we can consider the haze. Haze belongs to in which entity set? Customer. That is, if this is a E1 and this is E2, that means E1 here belongs to which entity set? Customer. And E2 belongs to which entity set? Please tell me. Account. Is it? Na? So, so this one is the what? Depositor relationship. Is it clear? The haze, comma A102. This is what? This is the depositor relationship that can provide the association between the customer haze with his account entity, that is the account number. Okay. Here, the same thing, that is the left side is the customer entity set, and this is the loan entity set. And by this is the association by this line. Suppose this is the John's, this is the loan number, L17 is the loan number. Similarly, Smith, the customer Smith can take in a two loan. The first loan number is the L23. What is the amount of loan? 2000, maybe rupees or maybe dollar. And Smith also taken another loan. What is the loan number? L11. And how much amount? $900. Say. Okay. So Smith, in this example, John have taken a one loan, but Smith taking a two loan from the bank. And you can see this one. I think the picture is clear. This one, that is L15, the loan number L15. What is the meaning of that loan number L15? This loan number L15, this loan, that is the $1,500, this loan taken by a joint customer, that is joint loan holder. What are the name? Williams and his. Okay, that is L15 is the loan number. This loan number is a joint loan holder. The name of the holder are Hayes and Williams. Okay, these are the relationship. That is this relationship. These are the relationships. These relationships is the basically borrower. Okay. Is there any question? So in this, up to my discussion, the relationship, this relationship I can say the borrower. In previous relationship, here actually I can say the this is a depositor. That can depositor is a relationship that can relate customer with the account entity set. But in this case, it can relate the customer with the loan. For that, we give the name borrower. Okay. So in depositor and maybe here in this page actually the borrower, both the relationship have no descriptive or additional attribute is there. But it is also possible the relationship set may have the attributes, some descriptive attributes. That is the relationship, the instance of the depositor relationship, it contains the customer and account number. Is it na? Whatever actually I discuss. This one. Let's see. Customer name and account number. This is the depositor relationships. So it customer and account attribute actually comes from the where customer entity set and account entity set, and this relationship have the one of the descriptive attribute. This is the access date, the when account access. Okay, last access. Okay, that means, so if access date is the one of the attribute, so how actually described by the relationship depositor? How described by the relationship depositor? How describe it, please tell me anyone. In previous case where the access date is not there, then how actually describe the depositor? By the customer name and what?
Access date, account number.
Account number. In that case, it is account number. That in in previous case, customer name and account number. Means where the no additional or descriptive attribute is present. But in this case, descriptive attribute is present
Access
in the
date.
relationship depositor. So here the attributes are customer name, account number, and access date belongs to what? Depositor relationship. Okay, is it okay or not? Is it clear na?
Clear, sir.
With the other students, do you have any problem? So response actually comes from
No, sir.
only
It's
4
clear.
5 students. Okay, so now the degree of the relationship set. This refers the number of participating entity set. That refer the number of entity set that participate in a relationship set. If the relationship set involves a two entity set, then it is called a binary relationship set. Okay, for example, depositor or borrower is a binary relationship set. Why? Depositor relationship associate the customer entity set and as well as the account entity set. That is the two entity sets involved in this relationship set depositor. Similarly, in case of borrower, the customer and as well as the loan. So these are the binary relationship set. Generally, most of the relationship sets in a database systems are binary, though they are maybe involved more than two entities set. For example, suppose the employee of a bank may have job or responsibility. You can say think about the responsibility at the multiple branch. Suppose the one of the employee work in a SBI bank SBI in the branch say RE College branch, that is the inside the NIT campus. That employee have additional charge in the say Ondal branch. Same bank SBI in the Ondal branch. Okay. So in that case, what happens? At that time, the three entity set is there. One is the employee entity set, another is the job entity set, another is the branch. The RE College branch is the one of the entity. RE College branch is the branch name. But there is some other attributes are there. The branch asset is there, branch address is there, branch code number is there, so on. For simplicity, I can say the only the branch entity set contain the branch name. Okay. So this here it involves a ternary relationship. What actually I want to say, suppose one of the employee, whatever actually I want to told you, say just a minute, say Ajit is the employee. Okay, Ajit is the one of the employee, have the responsibility X, perform in the branch, say RE College branch. Say branch name is RE College means say A. Okay, this is the responsibility. That means basically job. And this is this is the branch. That means this is the branch and this is the responsibility. And Ajit also perform the responsibility, another responsibility is say Y. The responsibility name is the Y. I am not saying the, suppose X, Ajit is the branch manager in the NIT Durgapur branch of SBI. Ajit perform the additional responsibility of say auditor or something, internal auditor of the Ondal branch. Okay, say Ondal branch is the say branch name B. Okay, Ajit also perform the another additional responsibility or job, say Z, in the branch say Benachiti. Say branch name C is the Benachiti. Okay, so in that case, this is employee. Just a minute. Employee, and these are the responsibility or job actually performed by the employee Ajit, and these are the different branch. The responsibility performed not a particular single branch, maybe in a multiple branch. So how actually relate here? Actually, you can see in this fact, three entity sets actually involved. What is the first entity set? Employee. Second entity set, job. Third entity set, branch. Okay, so this is, in this case, this is a ternary relationship set. Okay, and there are some others are also there, but and the relationship between more than two entity sets are very rare, and most relationships, whatever actually I told, binary, and from ternary to binary conversion is possible. How we can show later. Now next one is the the mapping cardinality. That is I already told before, the entity relationship model, the ER model represent a certain constraint. 2 is the content of the database must conform. One of the most important constraint is the mapping cardinality, which express the number of entities to which another entity can be associated via a relationship set. That is, the mapping cardinality is the one of the constraint. This is one of the important constraint which must satisfy by the content of the database, whatever the data stored in the database. Is it clear? What actually express? The mapping cardinality express the number of entities to which another entity can be associated via a relationship set. So most useful in describing the binary relationship set. And for binary relationship sets, the mapping cardinality is any one of the following type, 4 types: one to one, one to many, many to one, and many to many. Okay. Uh, first one to one. First one is the one to one. In case of one to one, say this is the entity set A. Say A is the one of the entity set, and say B is the another entity set. Okay. Here A1, small a1 is the entity of the entity set A, capital A. A2 is the another entity. A3 is the another entity. A4 is the another entity. A5 is the another entity. Similarly, here B1, B2, B3, B4. The 4 entities present in the entity set B. That is, A, B are the entity set. Okay. Now, in that case, the one to one means what? The number of entities. Suppose here A1 is associated with say B1. That is how many number of entities in set A is associated with another entity in B. Say this is B3. Say this is associated with B4. Say A5 is associated with B2. Okay. Okay. You can see here at most one entity in the entity set A is associated with at most one entity in the entity set B. So for that, it is called a one-to-one mapping. Is it clear? That is, only one entity, at most one entity in the entity set capital A is associated with at most one entity, maybe the zero entity, at most one entity of the entity set B. For example, A1 is associated with, A1 is associated with B1. Okay. Similarly, A5 is associated with B2. But there may be possible, say A4 is not associated with any entity in the other entity set B. Okay. This is a one to one. Mapping cardinality. Similarly, one to many. This is the A1, A2, A3, A4, say A5. Say another entity set B, B1, B2, B3, B4. Okay. Now suppose the A1 is associated with B1, A2 is associated with B2 and B3. Okay. Say A4 is associated with B4. So here actually you can see from entity set A, for example, A2 is associated with two entities in the entity set B, that is B2 and B3. Okay. So this side is the one and this side is the many. This side, similarly here, this side is one, this side is one also, at most one. So in this example, you can see just opposite side from B to A, the B3 is associated with at most one entity in the entity set capital A, that is A2. B3 is associated with A2, at most one entity. Any entity in the set B is associated with at most one entity in the entity set A. Okay. Can you tell me any example of one to one or one to many?
Sir, for one-to-one student and college.
Student and college.
One student can go at a time only one college.
Yes, that is a one student can associate it with one college at a time. Is it? And one college can associate any
Sir,
number
any
of students.
Sir, it
Any
is
number
will-
of students.
yes,
So
it
here
is wrong.
A is the
One to one.
what? A is the student or A
A
is
is
the
the
college?
college.
A is the college. Good. And B is the student. Okay.
College.
Yeah, A is the college. That is, suppose here A2 is the college. In A2 college, there are two students is associated, B2 and B3. But B2 students, no students can associate with more than one college. At most one college. Maybe associated or may not be associated something. Okay. Say another example. That is, this is actually just a minute. This is a college. This is students. Okay. Maybe if we consider, say this is the customer and this is a account. In according to our discussion, customer is the one of the entity and account is the other entity. So here this one to one is possible.
Not.
If we say the capital A is the customer entity set and capital B is the account entity set, then what is the meaning of that? The one customer have at most one account.
One account.
At most one account. That means this is one of the assumption or restriction. Means no customer can hold multiple account in the bank. Similarly, what is the another assumption in this case?
Restriction.
Single account, suppose the B4 account or maybe the B3 account or whatever, account can associate it with at most one customer. So what is the assumption there? There is a no joint account holder is there. Is it not? That is, single account can hold by a multiple customer. It is not possible in case of one-to-one. In case of one-to-one mapping. But in case of one-to-many mapping, what is possible? If we consider this is a customer and this is account, what is certain restriction is relaxed. What is mean? The single customer have any number of account. That is, you can open multiple account in the bank, but because it is a one to many, that means many to one from B to A side. That means a particular account can hold one customer only. That is, joint account holding is not considered in that case. Is it clear? Any confusion?
No, sir, it's clear.
Okay. I already told that some of the elements or entities may not be involved in the mapping. The another is the many to many. The many to many, just I draw the same to the one to many, just opposite of this. This is A1, A2, A3, A4. Sorry. This is a B1, B2, B3, B4. This is a B5. So, what is the many to one? Many to one means this side is one and this side is many. So, maybe A3 is associated with this. Maybe this one is associated with this. Okay, this is a many to one. That means A1 is associated with at most one entity in the set B, but B1 is associated with two entities in the entity set A. That means any number of entity in the entity set A. Similarly, another one is the many to many. That is, in case of many to many, any number of association is there. That is A1, A2, A3, A4, B1, B2, B3, B4. Maybe any number of association is possible. Okay, this is a many to many. So if we consider our previous example, whatever customer say, this side is the customer say, and this side is the say account or loan. So how we express this? That means in that case, the customer can open at most one account in the bank, but bank account say B1 is associated with two customers. That means joint account holding is possible in that case, in the many to one. Joint account holding is possible in many to one. And many to many, there is no restriction. The bank any customer can open any number of account in the bank, and also the bank account can be shared. Bank account can be held by a individual person, or maybe the bank account held by a joint or maybe multiple person. Okay. So many to many, there is a remove all the restrictions. Okay, we can continue my discussion in next class. But till up to my discussion, is there any question or confusion?
No, sir.
No, sir.
Okay, just a minute.
No, sir.